All right, well, welcome to our last edition of notes for this decimal unit. A little bit more on decimal division. I know it probably seems like the topic that will not die, but there's just a lot of details involved. So when you look at these examples right here, you think, oh, we've done problems like that before. That's just whole number division. True. However, previously we were just writing our answers as mixed numbers. We would take our remainder, if we had any, and put it over the divisor. And an advantage of that was division just, stops pretty early on. It's pretty nice. And another advantage I should have listed, let's add on, is you always have an exact answer. It's always exact. Well, you could actually keep dividing and write your answer in decimal form. The advantage to that is that lends itself to rounding more so. You can round to the nearest tenth, hundredth, thousandth, whole number, etc. Something you can't do when it's in fraction form. The biggest disadvantage, though, is sometimes it just keeps going and going and going without actually having a pattern of repetition, which is rather ugly. That only accentuates the reason why we need to know more than one way to express our results. So let's say you saw this problem and I wanted your answer in decimal form. We would just set it up normally, just start dividing so we know it goes twice. That's 64. Subtract. 32 into 62 won't quite go twice, so one time, and we get 30. Well, if we were writing it in fraction form, now is where we would put the 30 over the 32, but we're not going to do that. So we're going to insert a decimal, and we'll add zeros until we either get a repeating decimal, which I am going to talk about in part 2 here, or we get a remainder, or we get no remainder. So let's bring down this 0. So 32 into 300, just think 30 would go into 300 10 times. So 32 is not going to go as many. We might try 9. Maybe too big. 9 times 2 is 18. Carry the 1. Okay, so that'd be 288. So subtract and you get 12. Still got some remainder down there, so you have to keep adding zeros. So 32 into 120 is going to go, let's see, if it was 30, it would go 4 times, so it's going to go 3. 3 times 92 would be, 3 times 32 would be 96. I'm going to have to kind of sweep over here. Let's see, minus 96. Let's subtract. We get 24. Fortunately, every time I'm bringing down a 0, so if you can squeeze it in and go down lower on your paper, that would be great. So 32 into 240. Well, if it was 30, excuse me, it would go 8 times. So we have to add another 0 here. So it's not going to go that many times, so it's going to have to be 7. 7 times 2 is 14, 21, 22. Okay, still going. This is the unfortunate part. This is kind of the disadvantage. 24 from 40 is 16. Got to add another 0 and bring it down. And then 32 into 160, 30 times 5 would be 150. That's going to work out. That's 10. Yep, that goes exactly. Whew. So your final result is 21 and 9,375 ten thousandths. Awkward to say. So those are, a little unfortunate. The further you have to divide, the easier it is to make a little multiplication or subtraction error. Again, why you're going to depend on your partner somewhat. So over here, we're dividing 7 into 54. Now this one turns out to be particularly ugly. First, think of it if it were in fraction form, like so, and we were just making it a mixed number. It would be 7, that's 49. 49 from 54 is 5. Whenever the denominator is 7 in a fraction, unless it just turns out to be ugly. So those are really long, kind of ugly ones. I just want to show you how in fact, I better move over because this one goes a little ways. But we'll stop at some point on this problem, but I'm going to go ahead and just add some zeros because I know it goes pretty far. So 7 into 54 is 7. Try to write small on your paper so you have more room. You get 5, you bring down, you get 7 again. You subtract, you bring down. It's pretty easy division, easy subtraction. It just keeps going. 7 into 30, 4. Bring down, it goes twice. 14. See how it just seems to not want to stop? That's 8, and that'd be 56. So I'm just going to stop. Just to kind of show that sometimes this is one of those big disadvantages where it might just be better to work with the fraction form in a situation. And if I was rounding, depending on where I had to round, I could maybe stop early. So let's make a note here that I stopped early, kind of for self-preservation. But I wouldn't give you a problem like this to continue on until the end, where there's just 6, 7, 8 places after the decimal to keep adding zeros. But let's just practice a little bit of rounding here. This one, maybe to the nearest hundredth, would be 7.71. But if we were going to be exact, our exact result would be better to go fraction and just keep it as 54/7, or as we said before, 7 5/7. In teaching algebra, I know a lot of students actually prefer decimals, but the only reason they really prefer them is because of their calculator. And so what happens is, if they only know how to get ugly answers like the one we just got there on their calculator, it's not exact either, because the calculator will only hold so many places. So it's really important that you know how to work with fractions so that you can use that value to put in your problem so that you can be exact. Well, let's talk a little bit about repeating decimals. The previous ones did not repeat. Even the one that kept going, it wasn't repeating because we were getting different values each time in our quotient. But here, this one does turn out to be a repeating decimal when you start to divide. And we'll talk about the ways that you can write your result. Let's go ahead and get our decimal where it belongs. I can't emphasize that enough. Putting the decimal point up in your answer where it's going to go, and then just carefully lining things up. So 55 into 88 goes once. Bring down 55 into 335. Think 50 into 300 would be 6. So, try 6. 6 times 5 is 30. Okay, that's 330. Subtract. We're going to have to add a 0. Bring down. It does not go into 50, so you put a 0. Add another 0. Bring down. Think 50 into 500 would be 10. So, it can't be that big. Of course, you can't write 10 anyway. So you think, oh, well, I think if I put, it might be 9 or it might be 8. let's see, 55 times 8. That's 440, not enough. So it's going to go 9 times. So 9 times 5 is 45. Carry the 4. That's 49. That would leave us 5. So right here is where I start to notice, oh look, I'm going to get that 0 again. And then when I bring down another 0, it's going to go 9 times again and give me 500. So once you get here, you have an option. Once you show the pattern, like we've done right here, you can put the ellipses after it, the dot, dot, dot. That's one way. That's not usually how it's written. Or you write the decimal with what we call the repeating bar, and you put the bar over the portion that repeats. So if we had just put the bar over 9, we would be saying it was 16.099999. But now we know it's the 09 that repeats every time. The second way is really the more typical way that it's done. So 44 divided by 9. Now this one repeats as well, but it's a little bit different than the previous one. That's why I included it. So 44 divided by 9. Put our decimal where it goes. So we know 9 times 5 is 45, so it's just going to be 9 times 4. Subtract. We're going to get 8. We're going to have to add a 0. This is a good point. I remember last year some students were kind of putting the decimal down here. The only place you're interested in the decimal is in the dividend and in your quotient. Don't put a decimal in any of the other work in your division. 9 into 80 goes 8 times. That's 72. And right here you start to see, oh, I'm going to keep getting that 80, and I'll continue to have that 8 every time. So again, you can either do this or the more popular 4.8 with the 8 repeating. So this is another good example of when things are repeating, I can't actually substitute them in and calculate with them. So I would have to have the problem in fraction form. I might point out that this problem, before you start, since you notice they're both divisible by 5, you could actually, let's see, 10. Yeah, you could divide both of these by 5 just to give you some smaller numbers to divide here, but you certainly don't have to, but that's an option. Then the third part is you're going to have some word problem, and we've talked about this a little bit already, but sometimes it doesn't make sense. We talked about it with our fraction unit. It doesn't make sense for problems to have fractional parts in their solutions just based on what's in the problem. So you have to ask yourself, you know, is this a logical conclusion? So you really have to consider the question. So let's try this one. And this is our last one. So Mark wants to make bags of slime. Oh, that was very popular here last year. If each bag requires 0.15 kilograms of cornstarch, and he has 1.23 kilograms, how many bags of slime can he make? Well, if he's making slime and he has a total, this is his total. That's what he has to split up into chunks of this much. This is what he needs per bag. So for every bag, he needs that much. So I'm splitting up the total into however many groups I can get. So that's why I know it's a division problem. So I need 1.23 divided by 0.15. So we think about what we know. The divisor has to be a whole number. So I have to move it twice. So I have to move this one twice in my dividend. So really it just becomes 123 divided by 15. So come over, show our long division. All of this is our support. Put our decimal just in case we have to go a little further. Erase that. So let's see, 15 into 123. Well, 15 times 8 is 120. So subtract, since I didn't get a remainder, since I didn't get no remainder, a 0 here, I'm going to have to add a 0 and keep going. Oops, it goes into 30 evenly. It goes 2 times. 2 times 15 is 30. So now I might be tempted to just write kilograms there, but I need to think. It says how many bags can he make? Well, he's making not fractional parts of bags. So instead of 8.2 bags, we need to say he only has enough really to make 8 full bags. So 8 bags. There could be another instance where it makes more sense to round up. Say this was, I was trying to figure out how many cars I need to take a group of students somewhere. Well, if I need 8.2, 8's not enough, I'd need 9. So it depends on the problem, so you really need to just think about it, talk about it with your partner, and decide, does it make sense to round up or round down, or sometimes you just leave it. Because say we were measuring an ingredient for a recipe. Well, you can have a fractional amount of something to put in a recipe, or you can run a fractional number of miles. So sometimes it sticks, sometimes you have to round down, sometimes you have to round up. That would actually be a good thing to add to your notes. So sometimes you keep the decimal value. Sometimes you have to round up, and sometimes you have to round down. So just keep that in mind anytime you're working on your word problems. And that concludes all the notes that you'll be taking over the decimal unit. Yay!